like I started introducing in yesterday's class, I said in your data analysis journey, as you work with data in R, you are likely that the data will not come in a very clean format, isn't it? Okay? The data may not come in a very clean format. And it is your duty as data analyst to clean the data first before you start any modeling or any analysis. It's your duty to start to clean the data, and there are a number of methods and functions for cleaning data, but I will just highlight a few salient ones, important ones that are useful, isn't it? And then we can just go through them, how they are being used, and then before we go to visualization. The first one here is checking for missing values. Now we are going to look at a hands-on example. So the is not a number, it's a function, like I mentioned yesterday. It's a function. So when I say a function, you know what that means. It means it's a function that you call, then you open bracket, you supply something, and then you close bracket, like sum, mean, max, isn't it? So the is not a number, it's also a function. Now what does it do? It checks within your data frame and checks whether there is, you know that this NA, whenever you import any data frame and in a column you see NA, what does it mean? It means there's a missing value there, isn't it? So this particular function is NA, checks the data frame and see whether there are missing values in the data frame. And if there are missing values, it returns true. It returns true in that particular. For example, if you come here, let me see, I have a data here. Air quality is part of the popular data set we have. Okay. Air quality. If you check it carefully, you see it there. The way we have empty cars, we also have air quality. Okay? Can you see it here? It's the New York air quality measurement, isn't it? So it's a data set. Just like we have empty cars. So if you have data, is equals to empty cars. And then if you do, of course you can do head empty, you can do head data to get your data, to get a few of your samples. Now, if you want to check if there are missing values in this data, you call is not a number, it's a function. And what do you supply to it? You supply the data, the entire data to it, and then it returns all instances. If there are missing values, it says true. Is that okay? For every column, it checks every column one after the other. If there are missing values in a particular entry, it returns true. And if there are no missing values, it returns false. As you can see clearly, you don't have any missing value in the empty cars data set, isn't it? And that's why even if you come here and you sum, you do sum, is not a number here, you see that there's what? There's 0. It means there is no missing value in that particular data set. Now let's look at a classical data that has a missing value, isn't it? For example, the air quality, let's say data is equals to the air quality. You can take a look at a few rows on the data set. Okay, can you see? We just visualize the first 6 rows of the data, isn't it? And we see that, can you see here? We have some missing values here, isn't it? We have some missing values, we have some missing values here. And even if you do tail, let's look at the bottom, let's see, tail of the data. Okay, you can see that there are some missing values, isn't it? In fact, if you do summary of the data, no? If you do summary of the data, you will see that how do you say print? So you can see that for every column, this is important though. When you are given a data and you have missing values, it will not, if you invoke a particular column and you say you want to find the mean, it will give you error because there's a missing value there. So you need to find any practical data a missing value. Blank. You must actually check the mean of that data, isn't it? For example, this air quality, if you print it now, if you print the head, of the air quality, the first column is what? Is the ozone. I don't know that, maybe it's a geographical term. I don't know, in geography it makes sense to them. It's a measure of air quality, maybe the ozone for every one. So if you want to get the average of the ozone, based on our knowledge, what do? We simply say data, $, ozone, we take the mean of that, isn't it? You can see that we have what? We have not a number. Why? Because we have missing values there. Yeah. So it is your duty to be able to understand how to manipulate all these missing values, isn't it? And that's what we're doing here. So for now, you know what ISNA means, isn't it? ISNA is a what? It's a function that checks every, not count, it checks every element in a column. If there is a missing value, it returns true. For example, if you do is not a number of the data, isn't it? This is the entire air quality data, isn't it? I think it has 1, 2, 3, 4, 5, 6 columns, and then we have 153 rows, isn't it? Yes. Now look at it. Wherever we have true means there is a missing value there. There's a missing value here, there's a missing value here, isn't it? So, but if you want to count the entire missing values, I now said you simply come and say sum, then is not a number of that particular data, and then it tells you that there are in total 44 missing values, isn't it? If you want to check the number of missing values in the ozone column, what do you do? $, ozone, so just so that there are what? There are 37, isn't it? If you want to check the number of missing values in the other column, it is solar of R, isn't it? There are 7, isn't it? You can do for the individual, even though if you do the summary of the data, it tells you for every column the missing values there, isn't it? For the first column, for the ozone, we have 37 missing values. For the solar, we have 7 missing values. And for the, I think these are the only columns that have missing values, isn't it? Exactly. We know how to identify missing elements within a data frame, and we know how to count the number of missing elements in all the data frame or a specific column, isn't it? Now let's look at some other cool stuff.
Sir, please, before you proceed, okay. These things you are doing now, it's like they are not in the material, right? They are not in the...
They are immaterial. They are immaterial. I updated it. I said I will send the data, isn't it? It's based on my friend's question that I said let me update the material. Okay. Of course, this illustration is not there. I only have the key codes. That's why you're here. That's why you enroll for the class work to have the feel of. So in this case, let's assume I want to replace missing values with the mean of the column, for example. Anyway, if I want to get the mean of a particular column now, even though I'm aware that in the column there is a missing value, but I still want to compute, let's say, a function on it. Yeah, so there is this. We said okay, is now. This one is na.rn. This one is not a value dot remove. It's an associate parameter that you give to a function to ignore missing values, isn't it? Alright? Not a number dot remove. If you set this to true, it will ignore any missing value. For example, here, if I say data, okay, if I say mean of data $sign ozone, you say it's going to give us what? Not a number. Why? Because there is at least one 37, not a number. But you now say, please look in there, not a number, remove it, and then come. Wherever actual values, compute the mean. So it will come and do what? Anyway, before I do that, let me print the data of ozone first so I can see it. Oh, sorry, that would be what's data? And data $sign ozone. Apply that on ozone. Okay, it's because it's plenty, but that's why it's occupying. Okay, it's appearing like a data frame here, but it's a vector. Why? Because it's plenty. Oh, one is a vector, isn't it? That's what they are for 3. Yes. So this is the first one, second one, third one, till the last one. And we said the total are what? 150. So we want to now compute the mean of this number, 1 number plus 1 number. And whenever we see not a number, we what? We ignore it, isn't it? So that's when we use the na.rm, isn't it? The na.rm is usually used together with a function. So in that case, it will be what? It will be the mean of data.ozone, and then please, na.rm should be what? Should be true. Is that okay? So what are we doing now? We are saying from the data frame data, get the vector ozone and compute the mean. I know that there are missing values. Wherever there's a missing value, remove it. Is that okay? Is that okay?
Yes.
If you do that, you get a number 42 point, and that's what we have here. That we're saying for, look at it here, data $sign score for a particular column, for example, we check is not a number, data $sign score, and then we put in wherever we have that instance, we put this mean there. For example, now if we are those, you know, in the ozone column now, okay, there are 37 missing values, but if we want to replace each missing value in the ozone, what do? We call data $sign ozone. We check for is not a number. For what? For the data $sign ozone, isn't it? And then we feed in that, isn't it? Look at this. this data dollar sign score, this is a column. You know this is not a number, data dollar sign score will simply associate true or false to the what? To the column, right? The column will only have true, false, false, false. Wherever there is true, wherever it is true, it means there's not a number. Wherever there's a false, it's not a number. So in this case, those Boolean, you are mapping it to that original column, and then you're saying wherever it is true, put this number. Do you understand? One of the, you have to open your brain.
Suppose we shall transcript.
So why we shall conscripting? Look at it. Look at it, is not a number. Please look carefully. Is not a number. Data dollar sign ozone. What will this do? Let me call this one X.
It will show ozone.
Anywhere in the ozone there is not a number, it will show true. But anywhere that it is not, it's a real number, it will show false. So now if I come to this place and I say data dollar sign ozone, okay, and I open bracket here, okay, it means I want to enter a condition. You understand? I want to enter a condition now that can either give me true or false. Wherever it is true, you do something. Wherever it is false, you ignore it. Oh, remember where we say one is less than this, do that. So in that case, I can just say X. Remember? So say X now, like X, I can get X is what? Is not a number, data dollar sign ozone. Right? Yes. So now what am I doing now here? I'm saying I want to do something, but I am only interested in where X is true, isn't it? This is X now. Cool. Then you know nails, but I'm only interested in where X is what is true, because that's the missing value, isn't it? So I now said data dollar sign ozone, and what am I doing here? I'm getting the entire column. And I said I want to do something on only the instances where X is what? Is true. What do I want to do? I want to replace that with what? With the mean. If you compute the mean, you can just go and put it for 2 point whatever. But in programming, you can just combine everything all together, isn't it? For example, the mean is for 2 point something. We can just come and say the data as the mean of data dollar sign ozone, but not a number dot what? Remove what? True. But one of the confusing you can just calculate this one alone, get the value, keep it somewhere, and then X, get the value, keep it somewhere, and then so in this case, if you do that, okay, if you print data dollar sign ozone, the inda was earlier not a number, will be replaced by what? By the mean, by the mean, and you can see that there is no not a number now. How do we check if there's not a number here? How do we count the number of missing values here? I'm not asking you, I'm asking my friend. My friend from biology. Yeah? This guy, data dollar sign ozone, I want to check how many missing values are there. Yes, what missing value echo? You simply say sum of what? Eh? Sum of is now of who? Because it's now is a function. And it will be what? It will be 0, because we have replaced all the missing values with what?
This data dollar sign ozone, can it be replaced with X?
No. X is just a data frame that contains booleans, but either true or false. Look at it, man. The role of X it will go each and every one. This is the first guy, second, it's only where it sees true that it will go and replace it with what? With the mean.
Yana nufin za ka yi ƙara create wani variable ka sashi a ciki sai ka name variable in x. So instead of you calling down, you just call in the x.
What will initially count as X?
We can put it inside there now. Yes. Inside if you want to do it all together, but okay, this is the let's do it the lazy way. Go. Let's do the lazy way. Go. Same with the mean is what? Go. Now we say Farco data Farco is equals to what? Air quality. Go. Isn't it? What do we do now? Now let's understand this. What do we do now? We want to calculate the mean of the ozone column. That will say the X scope is equals to what? I can put anything. I can say mean or M. Okay, M of ozone. M of ozone is what? Is the mean of data dollar sign ozone, but I want what? Na dot what? Dot rm true. Isn't it? If I run this one, MO is going to be a number, isn't it? MO is going to be is 42 points. How can you find it? 42 points. So the inside MO is I'm using 42 points on. Now, what next? Let me get the instances where not ozone has a missing value. That will be what? That will be, let me call it X code. Yes. What do you say? X is now equals to what? It's not a number. It's checking for a is not a number. Of course, it's small letters. Is not a number of who? Data dollar sign what? Ozone. Isn't it?
This one, if you want to check it's not a number of the first data.
This one, I want to check for the first data alone. This X, I want to check for the ozone column. In any number. This is the code, isn't it?
Yes.
And if you do this now, let me use small x. If you do this now, let me use small x. It will give you, X will now be a vector that has the same length as what? As the ozone column. And actually it will not have real numbers. It will only have true, false. It's only going to be true where ozone is what? It's not a number, isn't it?
Yes.
Now, I now said, if I want to now do what? If I want to replace the ozone is going to be what? Data, the ozone column with data, maybe I can say y. Okay, I can say data dollar sign ozone. I want to replace wherever this guy is X code with what? I want to replace it with what? MO. Isn't it? Is that good?
Yes.
So if you run this now and you print data dollar sign ozone, you see that ozone will now be devoid of what? Not a number, isn't it? And now what I did now, I balkanized it into steps. Go. I now said, if you want to, what's the English word? If you want to begin me, what's the beginning? What's the you want to express me, eh? You say what? You say data $sign ozo into bracket x. Am I x in the name? The what they want to know, isn't it? Is equals to MO. Shukma MO is what? Is the mean of data $sign ozo. So this so I know if you do it in one line it can be tricky, but this is what we did. And I believe everybody here can translate what has happened here. Go. So I don't know. Is clear? It's not very clear. Yes, we'll not go beyond piping in this case. We won't go beyond piping. We are not going to go beyond piping. That's your back. But you have, wait, if you understand this, you don't say answer. If you understand this plan,
it's clear. No, the step is one and seven.
whatever happened as a machine, if I'm not should be in. What again? So the mean of data $sign ozo, comma, not a number. I'm not ozo in casa she don't know calculate can I say $sign then she comma ozo so don't make mistake. Don't type it, just rely on this so that you don't make mistake. You see, and then x is what?
Because they are not.
Yeah. $sign ozo. And then you know come out $sign ozo. So if you do this now, you should have everything in it. And then if you call the ozone now, you should see that it does
Assalamu alaikum. Ya yake?
so there will be no missing value.
Muna wani program ne? Yes, sir.
Okay. So let's go back to the slide. Okay. So now, So now another one is if you want to remove duplicate rows, isn't it? If you have some rows that are duplicate, isn't it? Eh? So this actually the command duplicated, isn't it? Isn't it? The command that checks for duplicate is duplicated, understand? And it's a function. Is that okay? That returns true or false for duplicated rows, isn't it? So if you want to now remove duplicate, you put question mark duplicated. Who can tell me the role of question mark here? It is not now. Not about true, eh? If something is true. If something is true and you put not true, it will return false, not? Yes. So not is just a negator, isn't it? So here we are saying from this data, okay, I want to get, so it means duplicated data. For example, if you come here and you say data, if you say duplicated data, what do you have? You have false. It's looking for duplicate, isn't it? Very good. So it's false now. And then if you come here and you say not duplicated, isn't it? Become what? True. So if you want to do something on a data frame, if you want to do an operation, you only do the operation on the true instances, isn't it? So in that case, here we check for the duplicated, isn't it? If it is duplicated, if you want to remove those that are duplicated, you simply call the data into the duplicated data, comma, isn't it? Because you want to take all the columns, isn't it? The duplicate checks it column by column, isn't it? You check here, sorry, row by. It checks for the duplicate row by row, isn't it? It checks for the duplicate row by row, isn't it? So even here it means there are some duplicated data. What? How many are there? None. No. What we are saying is that duplicated here, look at 1, 15, 29. Here you say duplicated data, isn't it? It means 1 is what? Duplicated, isn't it? Isn't it? Isn't it? This is the line number.
Yes.
Line number, isn't it? Line number number 1 is duplicated, isn't it? For example, say 1.
Is it not okay out of the whole data?
Sorry, you say duplicated data. The one that returns true is the one that is duplicated, isn't it? So this one is not duplicated. 15 is not duplicated. Okay, none is duplicated, isn't it? Because this is the first row. Cool?
Yes.
Because the total rows are 153, isn't it?
Yes.
Because it's huge. So this is the first row, second, third, fourth, fifth, sixth, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So
each row represents each force represents
each one the row that has been duplicated. So and here we're doing the same thing, but not duplicated is also true. It means none of them is duplicated. So now let's come here and see. So So well, every true or false is acting on the row. If you check duplicated, if you have a true, it's telling you that this row is duplicated. Have it?
Yes.
If you have a false, it means this row is not duplicated. So now look at this. And you know, if you are indexing a data, what do you index with? With two things: the row and the column. So in this case, that's why you have data. Okay. Then there should be something in the row and there's something in the column. If you put comma nothing, it means you want to get all the columns. And then here you are only interested in the rows. What rows? The rows that are what? That are not duplicated. So because this one, there is no duplicate, so even if you do it, it's going to be the same thing. And then let's look at this one. Na.omit. We've looked at is na.remove, and then na.what? And omit, isn't it? But na.omit is also a function, isn't it? Na.remove is just a parameter that you supply together with any function. But is na and na.omit is what? It's a function. So what this one actually, wherever there is a missing value, just remove it. You understand me? For example, this data. Let me run this one again because I've done some manipulations here, isn't it? I like the summary. Sorry, composing. The summary of this data is what? It says what? I think there are 37 NAs in ozone code, and there are 7 NAs in. But if I want to get a total, I will just say sum code is not a number of what? Of data code. Say 44, isn't it? It's 44. Now, what's the entire size of the data? If you do, for example, if you do tail.data, 153 go, isn't it? Yes. So if you remove 153 minus 44, what do you have? 109. It means there are, although we have 1 to 3 rows, what? Yes. There are 44 rows that have missing values. And if you want to do your analysis in which you only want to work with rows that are clean, so you can just want to say clean data, one of just a variable name, is equals to na dot what? Dot omit what? Dot omit what? Data. Isn't it? And if you do, let's say till clean data, you see that it has been removed, but the index is still there, isn't it? But if you do summary, okay, let me see, sum is not a number of what? Clean data. What do you have? You have 0. So it means this clean data has no problem with what? Has no problem with missing value. So for example, if you come to clean data and you take the ozone and then you find the mean of ozone, it will give you what? A number that, not a number again, because there is no missing value in what? In that. Is that clear? I'll leave it here so that we can go through visualization, isn't it? Because the class is finishing tomorrow, so that we just have a feel of. So this is an example of air quality that we looked at.
Just a question before.
Yes, sir.
You see, all these things you are writing, are there inbuilt of them inside the app? So that, okay, assuming I want to remove something, do I need to write it myself, or maybe there are some inbuilt inside, so that whatever I want to do, I'll go and check for this script, I'll call it or whatever.
So,
Just get it and
yes,
so I have to write everything myself and
no. That's why we have help, Aiko. Every can I help you?
Yes.
Every programming language has its this syntax. I don't is under is there are several functions that I don't even know of. Misali is kasa dot kasa is kasa dot kasa hyphen. Sorry kasa kana masawa dot. Kasnan dewa is array. It does something. It's atomic, it's called, it's character, it's complex, it's double. They are plenty. Nobody can cram everything, isn't it? But the most important thing is that you know how these things work. Now, if you want to check, I want to check whether this number is a complex number or not. Okay, what's the function? You just check it in the help, or you go to Google. That's why you know how to use R, isn't it? You're just looking for that function that can do it. You use it, isn't it? Who can memorize all these things? This one, they are all under ISFA. Under is that it checks for. If you come to now,
it's like dictionary.
You want to check not action, not not omit, not fail, not pass. Some of these things, even I don't know them. But of course, it is okay. But if I want to use anything, I will go and check for the documentation. There are cheat sheets that you can just look up. Okay, this is the function that does that. Isn't it? If you know how to check if a number, if it is not a number, so it's number. If you want to check if it is something else, you want to check is. If you want to check if it's a character, isn't it? If it's a character, in there, let's see, R. Because R is a character. And one year unless 25 is 65. It will return false because 65 is not a character. And I have never used its character in my journey of R. But if I want to use it, it's just to check which function checks for this, and then I use it, isn't it?
So again,
Yes, sir.
I mentioned something like hate before that quality. I don't know.
A head, if a data is huge, it has 1,000 columns or 10,000 rows. Can you, like the air quality now, like 153, but you just want to have an idea of, okay, what is you want to just look at the first 6 rows, isn't it? Or you want to look at the last 6 rows. That's when you use head and tail.
Is there a significant difference between the answers and the functions?
No. They are two different. They do two different things. The now dot omit is a function that takes in a data frame and returns another data frame with all the missing values, any entry that's missing value removed. Human now dot remove, it only suppresses not a number and allows you to perform an action on that particular vector. So I want to find the mean of a vector. I want to find the mean of a vector, but in that vector there is a missing value. If you find the mean with that missing value there, it will return NA for you. So you now say, okay, I know there are missing values, but wherever there's a missing value, ignore it. Just concentrate on the numeric values. That's when you use NA.rm. And that's why it usually comes as an associate parameter, isn't it? It's a parameter that you supply to the function. But Shipman now.omit is a standalone function that you supply in a data frame to it, and then all it does is that it removes any row where there is a what? Without any
missing one.
Yes. So if it has 10 columns and 9 columns have, maybe it has 10 columns, and let's say we are looking for the 5th row, and in that 5th row all the 9 columns have value, it's only the 10th column has not a number, it will remove it. You understand? Okay, so this is what I was explaining. If you want to check the air quality, I didn't use empty cast here. Why? Because empty cast is a clean data, isn't it? And I want to illustrate something on a dirty data, isn't it? If I want to show you how to omit missing values in empty cast, it will return the same thing, huh? Because there are no missing values. That's why I use another data set called. So these were. Let's also count missing values in each column. You know, when we did sum is not a number, then we supply the data frame. It calculates what? When I did sum, open bracket, is not a number, open bracket, the data frame. It counts all the missing values in one place, but if I want to check each column, how many missing values are there, isn't it? So that's why when you use what? Call sum. So you have to find off, you have to first of all, and you do the call sum on the what? On the result of the ISNA. Okay? You do the ISNA. The ISNA will return the columns. In each column you only have true, false, true, false, true, false, true, false. Go. Then the call sum will only go and sum in each column where there is what? Where there is true. Do you understand? Yes. It's clear. So call sum. And look at it. The call is in small letter and then the sums is in call sums. This type of variable name is what we call the camel casing. Camel casing. Camel casing. It's a popular way of naming functions and variables in programming languages, isn't it? Usually, you want to name a variable that has 2 names. Maybe my age. So you can come and say, well, my what? My a small letter. Okay. Then capital letter A. Okay. And age.
Just like you named my 5.
My 5, very good. My 5, and then capital letter F. Go. Then L. Camel. Before you have the legs and what have you. So that's why it's called camel casing. Isn't it? So this is a very horrid way of getting. So we've also seen this, right? Replacing missing values in the ozone column with the mean of the column. We've seen this one already. We call it on the ISNA, isn't it? And then if you want to remove duplicates, you simply call exclamation mark duplicated air quality, isn't it? So the duplicated is also a function. It's a function that is applied in the air quality, but it just like ISNA, it returns true or false. So and then now that omit will now omit the data, isn't it? So this is a summary of what we've looked at. And now let's look at visualization.
Sir, I have a question.
Okay.
For example, in the data frame, if I want to grade or maybe apply, let's say, another column for grade, such that all those that have 90 and above, maybe in a score, will have A. 80 and above will have B. Then 70 to 80 will have C. Then maybe 60 to 70 C. Then the remaining will have F. How am I going to?
You use your if-else function that we treated in the second class. The if-else statement. So maybe I'll look at it later. But now we want to look at visualization, isn't it? But it's very straightforward. You just call the function and then you do if statement that checks each column. If it is true, it returns that. Else, it does that. Else, That's else if, till you do the last one. Okay, visualization. You were given a data, you now know how to manipulate it, how to remove missing values, how to remove duplicate, and how to do this. And then maybe you want to plot, isn't it? And plotting is very essential because people do not understand numbers, they only understand plots, isn't it? So how do you do that? So visualizing data allows you to find insights in the data as well as create reports to showcase the data and its features. And R supports functions to create charts and graphs. And in today's class, we'll start with by making a simple chart data point, isn't it? So the first one is plot function. Please, I'll be holding here. It's very straightforward from the code. Once we do one, and you understand, the other ones is the same, only that the syntax, maybe if you know how to plot a bar chart, you supply in the column and then the parameters. If you want to do histogram, it's the same thing now, only to know that, okay, which function is for histogram, which one is for set. So the plotting function is something like this. So the plot function is used to create a chart. It can take a sequence of numbers as its parameters and use them as data points on the charts. And then it has a parameter, the mean, which gives the chart a title. And then you have the X lab and the Y lab, isn't it? This one is the X label. In some programming languages, it's called X label, like in MATLAB or Python. But in R, it's called X lab for the X label, Y lab for the Y label, and then you see, of course, the title is what? Is mean, all in what? All in small letters, isn't it? And then what you want to plot is what you supply in, isn't it? So for example, you have, I want to plot, let me say I want to plot, what do I want to plot? The number from 1 to what? The number from what? 1 to 100, isn't it? If I simply plot this, it is going to plot, but it will not give me, okay, the figure margin too large, let me make it 100. Okay.
What if it's a large data?
Figure margin, I'm coming.
Data check too much.
Plot 110, what's happening? Plot 1 to 10. Okay, this let's see, plot 1 to 50. This one. Okay. If you want to plot, let's see the number 1 to 10, and then the label for the plot. In this case, there is no any label, isn't it? The label for the chart is mean, isn't it? Go. And then this is the label, isn't it? Maybe what? My first chart, isn't it? And then the X label, that's the X axis one. You see X lab go. It's equals to what? This is what you can call it what? X axis go. And then what? Y lab is what? Call it you call it Y axis. So if you plot this, what do you have? You have your X axis, okay? You have your X axis here, okay? your x-axis, you have your y-axis, then you have your what? You have my first chart, isn't it? So whatever you put in mean is what appears here. Whatever you put in the x-lab is what appears here, isn't it? And whatever you put here is what appears in okay. We used a sequence of numbers in our previous example for our sample chart data. And in that case, both x and y coordinates of the points were taken from the sequence, isn't it? You know, in real life, if you want to plot something, you plot x against y, isn't it? But in this case, we only supplied x. We only supplied in the sequence. That's why it used the both value for the x and y from the sequence, isn't it? So we can also provide the plot function with the x and y coordinates separately as vectors. For example, let's use the empty cast data set, isn't it? The WT and the dragged. Go. WT and the dragged columns as x and y coordinates, isn't it? Isn't it? So in that case, I want to plot the WT column against what? Do you know how to plot now? WT and dragged, go. Where is it? If you see empty cast $, WT, go. Isn't it? And then if you do empty cast $, dragged, go. So if I want to plot this, what am I doing? I'm saying I have a plot, go, isn't it? I have a plot. When the value of x is 2.6, what's the value of y? 3.9. When the value of x is 2.875, what's the value of what? So you do that, kanasawa point, go. You have plots. When x is this, kanasawa point, go. When x is, at every day you draw a line. So that's what is happening here. So we plot x, plot y. X lab is the weight, go. WT is the weight. And then y lab is what? Rear axle ratio, isn't it? So in that case, you can simply come here and say what? Plot. You can put everything in one place if you like, but you can decide to just split it. In this case, our x-axis is what? Our x-axis is empty cast $ weight, go. And then our y-axis is empty cast $ brat, isn't it? And in this case, I'm plotting what? You plot x against y. So x first before y, go. So you have x, comma, y, comma, let's name the chart. Let me say WT, go. Or let me say weight, go. Weight, plot of weight, go. Against what? Against draft, go. Rear axle ratio, go. Isn't it? What's x lab? X lab is the weight. And then x lab is the rear axle ratio. Go. Isn't it? So if you do this and you run this, you see what? This is what you have, go. You have the plot of weights. This is the name of the plot, isn't it? And then here we are plotting the weight against the rear axle ratio. So can you now see the importance of plotting? Of removing duplicate values. In the actually, duplicate values are column in weight. There will be problem, isn't it? There will be error. So that's why it's always important for you to handle missing values.
So if you want to add units, like the weight.
Yes.
So
So you can just come and say the weight in what? In what's the unit of weight? Kilogram, go? The SI unit, gram or kilogram in SI unit, But let's say in grams, go? And then real axle ratio, isn't it? Has no unit. So once you run this, it's going to show you that, isn't it? Okay. Okay, you're going to see that it is it's a plot of weight in grams and then real axle ratio in.
So if you want to edit, sir,
You
do it there or?
If you want to edit what?
The graph.
Can you edit? You have to copy it.
Like the title of the.
And here now you read in the code. Sali now casa gram ba.
After running, but I can edit, but that's what it is.
Like the title, some assume that it should be beneath the figure.
No, but if you call the title on, if you call the mean here, it appears at the top. It appears at the top. So if you want to make it a title, you have to go and type it manually in your Microsoft Word. Yes. Yes.
Then this one will just copy it and take it to the Word.
Yes, you can just export well. You can save as PDF. Or you can just copy as image, or just copy to clipboard. Okay, copy into clipboard. You just go to your Word, and then you paste it, and then you analyze your data and give your boss. Isn't it? Okay, let's continue. No, the plot that we did was just putting the point. What if you want a continuous line? You know, if you plot, maybe in physics, if you plot, if you are doing Ohm's law, you take your own your current and then the potential difference. You know, at the end of the day, you are going to draw a line, and then the slope will not be the resistance, or the inverse of the resistance. So if you want to plot that, the plot function can be used to draw line graphs, and all you need to do is just to specify the type of parameter and use the value L, isn't it? So once you type L, just the way you did that, like that, type L, it will go and make it like that. So in your function here, just come here and see the type is what? No, whether in the first part or the second part, is going to. Okay, but this doesn't make sense, no? Isn't it? So there's in a day I'm not maybe for no come. Go. I'm not going to 1 to 100 musali go. Isn't it? It's going to be what? It's going to be a line graph. Go. So this will draw a line connecting all the points in the chart. So in R, the plot function is usually displayed in the active graphic device. Go. Whatever we plot, it's coming here, go? Isn't it? So what if you want to save it in a file? You can export manually, but there is a command that can do that automatically for you. You just go and keep it in your directory. So in R, the plot is usually displayed in the active graphics device. If you are using R Studio, it manages graphics devices automatically. However, if you're using R in a different environment, you might need to explicitly open a graphics device function like the MPG, JPEG, or you can run R codes in Jupyter Notebook, Anaconda. But in that case, it does not have it's like a web interface. So if you plotting Abu, you want to just keep it somewhere so that you can. So in that case, you can simply use functions like the PNG. You know, PNG is a popular file format for pictures, or the JPEG, or even PDF for PDF before creating the work. So, you just come and say PNG is a function, PNG, and then the name, how you want it to appear in your directory, PNG, JPEG, PDF, But then, if you do that, you have to close it, You close the graphic device, isn't it, so that it will not chop up your memory, isn't it? Dev.off. So, what do you have? Let me say one is what? Let me call this Let me do PNG Maybe PNG?
Yes.
And then I call it the file name must be there, okay? If you're using PNG, the file name must be there. If you're using JPEG, the file name would be JPG, So, let me call this one is Yusuf.what? PNG, isn't it? And then at the end of the day, I need to what? Dev.what? .off, Isn't it? So one name is in Nyaka. If you run this code, you know, if you get working directory, you are in the what? You are in documents, Okay? So if you run this code now, and you go to your documents, isn't it? If you go to your documents now, you should see, where is Yusuf? So have you seen Yusuf? So if you open it, it will just go and keep that particular plot for you, as an image. If you want it as PDF, what will happen? You simply put what? PDF here, PDF, and then you have Yusuf.pdf. Okay? And then if you run this, okay, and you go back to your documents, you have what? It's clear now. Are we together? Prof, welcome. Welcome, sir. Sir?
I said, let's come and has to be punished.
No. How about So whenever you call the W, do you know that you can draw multiple lines on a graph using the lines function? You can draw multiple plots in one place using the line function. Okay? So you know this plot will plot the first one, right? So if you want to plot another one on it, you just use the lines, isn't it? For example, now look at it. PNG chart.png. Line 1 is a vector 0, 8, 14, 42. Line 2 is what? 2, 4, 6, 8. Plot line 1 type is what? L. Maybe I don't type L. It's going to draw it. And then the color blue, isn't it? And then lines 2 is what?
Type L.
Yes.
Color red.
Yeah. So if you do this, it's going to show you.
Okay, is it color?
So maybe I can just come. go to my studio and copy this. Okay, if you run this, you go back to chart code. You see that it will plot the first one. Sorry, I correct. Let me use PDF code. Let me use PDF. Who can tell me Mr. Viva?
Come on, Casa bracket net.
No.
Okay.
Mr. Bayi? No. Whenever you open a graphic device, you have to close it. Dev.off, yes. Dev.off, isn't it? Yes. Yanzu in kai run din shi. Chart ne ko? Chart.pdf.
So even the PNG could have done it.
Yes. It's still open in a different. And you call PNG for?
Wani ba kuma na kuma wani ki tabu da okay, amma da wannan sama ke dev bot wannan
shi kan shi din da nayi ban ma kulle shi ba sai na kulle shi dole shi ma kafin dev.off. Okay, dev.off ko dev.off ko na sani. So I have to come here and put dev.off ko. If not, it will not show the graph. Chart.png yanzu ko PNG. This is the first one, this is the second one. And even the PDF, so if you do that, you obtain something like this. Go.
I think I'll replace when you do that. Better you know like
so apart from line graphs, you can also do bar charts. Go. You can also do bar charts. The bar chart function can be used to draw a bar chart. For example, let's create a bar chart for the HP column of the empty class. We all know what a bar chart is now. It just plots each entity individually according to what? According to its value, isn't it? So if you do bar plot empty cast, what do you have?
bar plot HP information HP.
So if you do that, you get something like this, isn't it? Isn't it?
Yes.
And in order to give bar chart, each bar a label corresponding to the row names of empty cars, you can set the names names.arg parameter. So if you do bar plot empty cars, if you do bar plot empty cars $HP nego. If you do this, you have something like this, go, which you can zoom to see it, isn't it? See that? You see that the bar no information isn't it? So if you want to now do that, then you have to come and put what? So names.argument, isn't it? Names.argument. That's it's taking the row names, well, for each car, isn't it? It will give you something like this. So if you want it to come, because there are plenty, the cars in empty cars are plenty. If you want it to come in this, you can just supply this last parameter. Just the same way we supplied na.rm in mean, you can also supply last.to. So the last.to equals to argument controls the orientation of the x-axis label, and it stands for label style. And setting it to 2 makes the axis labels perpendicular to each other, making it easier to read, isn't it? So this is how the bar chart works. Maybe we'll stop here, continue tomorrow. I'm tired of talking.
How do you enlarge those, the outcome of the charts?
How do you?
How do you enlarge them?
Okay, in the Art Studio, no, you just hit zoom here. You can click in zoom, and then if you even maximize it, it will even open it bigger. It's clear? Yes, sir.
So the function xlab, ylab, main, is it applied only to?
It's applied only to plots. Yes. Yes.
So for bar
If you do for bar chart, let's try it and see. Let's see mean is equals to, let's say my bar chart. So it's applied to everybody. Yes. So even if you do xlab here, xlab here, let's say it's equals to x-axis, and then ylab is equals to y-axis. If you do that, yeah. So it's applied to any type of plot, irregardless, isn't it? Please, we'll continue tomorrow.
No question.
Tomorrow, if I come, I will finish the visualization, and then I will introduce us to a concept called piping. Piping. Yeah. And then we'll not go beyond. We're not going to go beyond that.
Say advanced class. Say in advanced.
Whoever wants to go advanced, then we organize an advanced class, isn't it? But because I've measured the body language of the participants, it seems, if you are learning, you just want to stop there and rest and pause for like, in education, there's a name they call it, but something fatigue, something you, even if you are reading something or you are learning, let me stop here and yeah. So when we rest, then we can come back for the advanced class. Thank you very much. Tidy verse. Yeah, I'll introduce you to at the peripheral tomorrow. But that's where you enter that's the advanced. Whatever we've been doing now is sufficient for you as a base R analyst. But when you want to do tidy verse, so it's a suite of advanced tools that makes even data analysis more fun and easier. Yeah, and there are several other libraries under tidyverse, dpila, etc. Thank you.
No question. started on.